Implementation of India's AMCA program by 2036, 4 phases with $6 billion budget allocation and advanced AI integration. Introduction. India's Advanced Medium Combat Aircraft AMCA program is set to be a transformative initiative in the nation's defense landscape with a planned completion by 2036. This ambitious project, with a budget of approximately $6 billion, aims to elevate India's indigenous capabilities in military aviation through a structured 4-phase development plan while also integrating cutting-edge artificial intelligence AI technologies to enhance operational performance. Phase development timeline. The AMCA program will unfold in 4 distinct phases. 1. Phase 1 Initial Development. This phase focuses on establishing foundational technologies for the AMCA, drawing heavily from systems and technologies developed during the Light Combat Aircraft LCA program. By utilizing existing resources, the program aims for the first flight of the AMCA by 2028. This initial phase is crucial for laying the groundwork for subsequent developments, ensuring that the aircraft can leverage proven technologies to expedite progress. 2. Phase 2 Prototype Testing. After the first flight, Phase 2 will consist of rigorous testing of prototypes. This stage will focus on refining the aircraft's systems and capabilities, incorporating feedback from the initial flight. Expected to occur around 2030, this phase will be critical for identifying any necessary adjustments before moving on to operational testing. 3. Phase 3 Operational Testing. In this phase, the AMCA will undergo comprehensive operational assessments, likely beginning in the early 2030s. This testing will ensure that the aircraft meets the stringent requirements of the Indian Air Force IAF, including performance, reliability, and combat readiness. For phase 4 Full Operational Capability. The final phase will see the AMCA fully operational and integrated into the IAF fleet by 2036. This phase aims to not only confirm the aircraft's performance and capabilities but also to ensure that it is effectively deployed in real-world scenarios. Budget and resources. The AMCA program's projected budget of $6 billion highlights the Indian government's commitment to strengthening its defense capabilities. This substantial investment is essential for research, development, and production, allowing India to enhance its indigenous military aviation technologies in an increasingly competitive global defense landscape. The AMCA program aims to address current gaps in India's fighter aircraft capabilities, particularly in the context of regional security dynamics. AI integration. A standout feature of the AMCA program is the planned integration of advanced AI systems. This technological incorporation is designed to enhance various operational aspects of the aircraft, including autonomous operations. AI will facilitate advanced autonomous flight capabilities, enabling the aircraft to operate with reduced pilot intervention in certain scenarios. Targeting systems. The integration of AI will improve targeting accuracy and decision-making processes, allowing for more effective engagement in combat situations. Enhanced situational awareness. AI systems will process vast amounts of data in real time, providing pilots with critical information to make informed tactical decisions. This emphasis on advanced AI integration positions the AMCA as a modern combat platform capable of addressing the challenges of future warfare. Common key points. Analysis of various sources reveals several consistent themes regarding the AMCA program. The reuse of LCA systems is a recurring theme across all reports, emphasizing a strategy to accelerate the AMCA's development by leveraging existing technologies. The target for the first flight by 2028 is consistently highlighted, indicating a focused and ambitious development timeline. The significant budget allocation underscores the Indian government's commitment to enhancing its defense capabilities. Differences between sources. While many sources emphasize the integration of AI technologies, others focus more on the financial aspects and challenges associated with developing indigenous fighter aircraft. Some reports reflect varying levels of confidence regarding adherence to the established timelines, highlighting the complexities involved in such a large-scale defense project. Conclusion. In summary, the AMCA program is a strategic initiative for India aimed at bolstering its defense capabilities through a phased development approach and substantial financial investment. The commitment to achieving a first flight by 2028 serves as a critical benchmark for the program's progress, while the integration of advanced AI technologies underscores a forward-looking vision for modern combat operations. As the AMCA project unfolds, its successful implementation will not only enhance India's indigenous military capabilities but also contribute to regional stability and security in an increasingly complex global environment. The AMCA represents a significant leap forward in India's defense technology, aligning with the nation's broader objectives of self-reliance and strategic autonomy. The implementation of India's Advanced Medium Combat Aircraft AMCA program by 2036 is structured into 4 phases backed by a $6 billion budget and emphasizing advanced AI integration. This strategic initiative aims to bolster India's defense capabilities and involves several counterintuitive aspects that diverge from typical expectations in military aircraft development. Counterintuitive aspects of the AMCA program. 1. Reuse of existing technologies. While one might expect a program of this magnitude to develop entirely new technologies from scratch, the AMCA program strategically leverages technologies from the Light Combat Aircraft LCA program. This approach accelerates development timelines and optimizes costs, showcasing a pragmatic rather than purely innovative mindset. 2. Phased development strategy. The AMCA's 4-phase rollout contrasts with the common perception that advanced aircraft projects must aim for immediate full-spectrum capabilities. By breaking the development into phases, focusing first on foundational technologies and subsequently on prototype and operational testing, India is adopting a more measured and realistic approach to complex aircraft development. 3. Focus on AI integration. The emphasis on advanced AI integration is significant, yet it may seem counterintuitive given the traditional reliance on human pilots in combat scenarios. The expectation is that AI will enhance operational capabilities such as autonomous functions and advanced targeting systems, challenging the notion that human decision-making is always superior in combat situations. 4. Budget allocation. The $6 billion budget, while substantial, may appear limited for a modern fighter jet program. This allocation reflects a prioritization of budget efficiency and a focus on indigenous capabilities, which is unusual in an era where defense spending often balloons without clear accountability or strategic direction. 5. Timeline for first flight. The timeline to achieve the first flight by 2028, while ambitious, is rooted in the reuse of existing LCA technologies, suggesting that rapid progress is achievable. This contrasts with the often extended timeline seen in similar programs globally, where delays are common due to unforeseen technical challenges. 6. Operational testing approach. The early operational testing phase, scheduled for the early 2030s, suggests an aggressive timeline that assumes the prototypes will meet stringent requirements. This contrasts with the common trend of extensive prototyping and delays before operational assessments begin, indicating a confidence in the engineering approach being taken. 7. Indigenous capability emphasis. While many nations rely heavily on foreign technology and partnerships for advanced military aircraft, India's push for indigenous development through the AMCA program reflects a counterintuitive strategy in a global context where many countries prioritize foreign acquisitions for faster results. 8. Potential for overlapping phases. The description of the phases implies a linear progression, yet the actual development may see overlapping activities such as simultaneous testing of prototypes while continuing to refine earlier phases. This agile approach is contrary to the traditional waterfall model often associated with large defense projects. 9. Public disclosure and transparency. The level of public detail provided about the AMCA program, including timelines and budget estimations, is somewhat atypical for defense projects, which are usually shrouded in secrecy. This transparency might suggest a shift toward greater accountability and public engagement in defense spending. 10. Challenges acknowledged upfront. The AMCA initiative acknowledges inherent challenges in indigenous fighter aircraft development without shying away from them. This upfront recognition of potential hurdles contrasts with the often overly optimistic assessments seen in other military programs, allowing for a more realistic and adaptive planning process. In summary, the implementation of India's AMCA program by 2036 encompasses several counterintuitive strategies that challenge conventional expectations in defense project management, technology development, and budget allocation. These approaches may ultimately position India as a more agile and competitive player in the global defense landscape, fostering innovation while leveraging existing capabilities. The report on India's Advanced Medium Combat Aircraft AMCA program outlines a significant development in India's defense capabilities. Yet there are several important details that may be overlooked by readers. Herein we will highlight these elements and explain their significance. 1. Integration of existing technologies from LCA. The AMCA program's reliance on the systems developed for the Light Combat Aircraft LCA program is crucial. While many may focus on the new technologies being introduced, the strategic reuse of existing systems cannot be understated. This approach serves multiple purposes. Cost efficiency, by utilizing already developed technologies. The program can potentially reduce costs associated with research and development. The $6 billion budget may be more effectively allocated to new components rather than starting from scratch. Accelerated development timeline. The significant emphasis on achieving the first flight by 2028 suggests that leveraging existing technologies is a key strategy for meeting this deadline. This might not only speed up the process but also enhance the reliability of the aircraft based on proven systems. 2. Phased development strategy. The AMCA program is organized into 4 distinct phases, a detail that might be overlooked in favor of focusing solely on the budget and AI integration. Each phase is designed to build upon the previous one, allowing for iterative testing and refinement. Phase 1's foundation. The initial phase emphasizes foundational technologies. This stage is critical, as it sets the groundwork for all subsequent phases. The focus here is not just on immediate technological needs but also on establishing a robust framework for future developments. Prototype testing and operational assessments. The transition from prototype testing to operational assessments in the early 2030s is a significant milestone. It highlights the program's commitment to rigorous testing, which is essential for ensuring that the aircraft meets operational standards and can effectively serve in real-world scenarios. 3. AI integration as a game-changer. The planned integration of advanced AI technologies is a pivotal aspect of the AMCA program, yet it may not receive the attention it deserves in discussions. The potential applications of AI in the AMCA include autonomous operations. AI could enable the AMCA to perform complex maneuvers and missions with a degree of autonomy, reducing the cognitive load on pilots and increasing mission effectiveness. Enhanced targeting and decision-making. The integration of AI could lead to improvements in targeting systems, allowing the aircraft to identify and engage threats more efficiently. This capability is increasingly critical in modern warfare, where speed and accuracy can determine the outcome of engagements. 4. Significance of budget allocation. While the $6 billion budget is frequently mentioned, the implications of this investment may be underappreciated. The budget reflects strategic commitment. The substantial financial commitment indicates the Indian government's serious intent to bolster its defense capabilities amid regional security challenges. This may enable India to position itself more favorably in the global defense landscape. Long-term vision. The budget allocation also signals a long-term vision for indigenous defense production. By investing heavily in the AMCA, India is not only looking to fulfill its immediate defense needs but also aims to foster a self-reliant defense industry that can innovate and compete internationally. 5. Regional and global implications. The development of the AMCA has broader implications that may be overlooked. Regional security dynamics. As India progresses with the AMCA, it could shift the balance of power in South Asia. The advanced capabilities of the AMCA may serve as a deterrent against regional adversaries influencing defense strategies across the region. Global market positioning. Successful implementation of the AMCA could position India as a key player in the global defense market, particularly in the domain of fighter aircraft. This could lead to potential export opportunities and strengthen international defense partnerships. 6. Indigenous capability development challenges. While the report provides an optimistic view of the AMCA program, there are underlying challenges in indigenous defense manufacturing that merit attention. Historical lag in development. The report suggests that India has lagged behind in developing indigenous fighter aircraft. This historical context is significant as it highlights the challenges the AMCA program may face, including the need for skilled labor, technological innovation, and production capabilities. Potential setbacks. The ambitious timeline and budget may face unforeseen hurdles such as technological setbacks, budget overruns, or shifts in political priorities. Recognizing these potential challenges is crucial for setting realistic expectations regarding the program's success. Conclusion. The AMCA program is an ambitious initiative that embodies India's commitment to enhancing its defense capabilities through strategic development, substantial investment, and advanced technological integration. Key aspects such as the reuse of LCA technologies, a phased development approach, AI integration, budget implications, and the regional impact are all critical to understanding the full significance of the program. By highlighting these often overlooked elements, one can better appreciate the complexities and challenges inherent in transforming India's defense landscape by 2036. The implementation of India's Advanced Medium Combat Aircraft AMCA program by 2036 is a pivotal initiative that aims to enhance the country's defense capabilities through a structured and phased development approach backed by a significant budget allocation and advanced AI integration. Here are the 4 most valuable points for in-depth analysis and discussion. 1. Phased development approach. The AMCA program is structured into 4 distinct phases, which reflects a methodical and strategic approach to aircraft development. Phase 1, Initial Development. This phase focuses on leveraging existing technologies from the Light Combat Aircraft LCA program to establish a solid foundation for the AMCA. The goal is to achieve the first flight by 2028, indicating a targeted timeline that prioritizes technological readiness and operational requirements. Phase 2, Prototype Testing. Following the first flight, rigorous testing of prototypes will refine the AMCA's systems and capabilities, slated to occur around 2030. This phase is critical for identifying and addressing any technical challenges before moving to operational assessments. Phase 3, Operational Testing. Expected to begin in the early 2030s, this phase will ensure that the AMCA meets the operational needs of the Indian Air Force, emphasizing the importance of thorough evaluation and validation of the aircraft's performance in real-world scenarios. Phase 4, Full Operational Capability. The culmination of the program, anticipated by 2036, will see the AMCA fully operational and integrated into the Indian Air Force's fleet. This phased development not only mitigates risks but also allows for adjustments based on feedback and changing defense requirements. The phased approach underlines the Indian government's commitment to a steady and reliable advancement of its indigenous defense capabilities, ensuring that each stage of development is meticulously planned and executed. 2. Significant budget allocation. With a budget allocation expected to surpass $6 billion, the financial commitment to the AMCA program highlights the Indian government's seriousness towards enhancing its defense capabilities. This substantial funding is crucial for research, development, and production processes, reflecting the importance of self-reliance in defense manufacturing in the face of global security challenges. The budget not only supports technological advancements but also aims to stimulate domestic aerospace industries and create employment opportunities, thereby boosting the overall economy. Analyzing how this budget is allocated across the various phases of development could reveal insights into the prioritization of resources and the potential for partnerships with private sector players and foreign defense contractors. 3. Integration of advanced AI technologies. A distinguishing characteristic of the AMCA program is its planned integration of advanced artificial intelligence systems, which is indicative of a modern approach to combat aircraft design. The integration of AI is expected to enhance the aircraft's capabilities in several areas, including autonomous operations, advanced targeting systems, and improved decision-making processes. This could significantly increase the operational effectiveness of the AMCA. AI technologies could also facilitate real-time data analysis, enabling the aircraft to adapt to dynamically changing combat environments, which is crucial for modern warfare. The discussion around AI integration raises important questions regarding cybersecurity, ethical considerations in autonomous warfare, and the need for skilled personnel to manage and operate AI-driven systems. 4. Challenges and strategic implications. While the AMCA program is ambitious, it also faces several challenges that merit in-depth analysis. Technological hurdles. Developing advanced systems and integrating them into a cohesive platform poses significant technical challenges. The reliance on existing LCA technologies may expedite development but also risks perpetuating existing limitations. Geopolitical context. The AMCA program is being developed against the backdrop of regional security dynamics, particularly concerning China and Pakistan. The capabilities of the AMCA will play a crucial role in determining India's air superiority and strategic deterrence. Indigenous capability development. The success of the AMCA program is not just a matter of technological advancement but also of building a sustainable domestic defense industry. The ability of Indian firms to innovate and produce high-tech defense equipment will have long-term implications for national security. Each of these points opens avenues for deeper discussion regarding the implications of the AMCA program for India's defense posture, its economic impact, and the broader context of global military advancements. The successful execution of the program could position India as a significant player in the global defense landscape while also addressing its own strategic needs. 1. United States F-22 Raptor program. The F-22 Raptor, developed by Lockheed Martin, is a fifth-generation stealth fighter aircraft that serves as a cornerstone of the U.S. Air Force. The program began in the 1980s with a budget exceeding $60 billion. The F-22 combines advanced aerodynamic stealth and supercruise capabilities. Its development included multiple phases, starting with technology demonstration followed by prototype testing, operational testing, and full-scale production. The F-22's first flight occurred in 1997 and it was declared operational in 2005. The integration of advanced technologies including AI and sensor fusion has made it a benchmark for modern combat aircraft. 2. European Union's Eurofighter Typhoon program. The Eurofighter Typhoon is a multinational project involving the UK, Germany, Italy, and Spain aimed at creating a modern multi-role combat aircraft. The program's origins trace back to the 1980s with a total development cost around €100 billion. The Typhoon underwent several phases including concept development, prototype testing, and operational testing, before entering service in 2003. It features advanced avionics, air-to-air and air-to-ground capabilities, and is designed to incorporate future technologies including AI enhancements to improve combat effectiveness. 3. China's Chengdu J-20 program. The Chengdu J-20 is China's first stealth fighter developed by Chengdu Aircraft Industry Group. The program began in the early 2000s with a reported budget of over $10 billion. It went through various phases including preliminary design, prototype development, and flight testing, with its first flight occurring in 2011. The J-20 aims to provide China with advanced aerial capabilities, and it incorporates cutting-edge technologies including stealth features and high-level avionics. As with the AMCA program, the J-20 emphasizes indigenous development and advanced technology integration to enhance national defense capabilities. The Advanced Medium Combat Aircraft AMCA program represents a significant leap forward for India's defense capabilities. With a structured approach and substantial investment planned for its development by 2036. Here's a detailed outlook on the future of the AMCA program, focusing on its 4 phases: budget implications, advanced AI integration, and potential impacts on India's defense landscape. Future outlook on the AMCA program by 2036. 1. Phased development approach. Phase 1, Initial Development 2025 to 2028. The program will leverage existing technologies from the Light Combat Aircraft LCA program to accelerate development. Given the ambitious goal of achieving the first flight by 2028, the focus will be on creating a prototype that demonstrates essential capabilities. As the foundation of the program, this phase will establish design parameters, integrate preliminary systems, and initiate testing protocols. Phase 2, Prototype Testing 2028 to 2030. Following the first flight, the testing of prototypes will begin. This phase will involve extensive evaluations of flight performance, handling characteristics, and system integrations. It is expected that challenges identified during this phase will lead to design modifications, refining the aircraft's capabilities and laying the groundwork for operational testing. Phase 3, Operational Testing, early 2030s. During this phase, the AMCA will undergo rigorous operational assessments to ensure it meets the stringent requirements of the Indian Air Force. This stage will be critical in validating the aircraft's combat capabilities, survivability, and integration with existing defense systems. Phase 4, Full Operational Capability by 2036. By the end of this phase, the AMCA is expected to be fully operational with integration into the IAF fleet. The completion of this phase will signify a major milestone, marking India's transition to an advanced indigenous fighter aircraft capability. This phase will also involve deploying the AMCA in training exercises and real-world operational scenarios, further solidifying its role in India's defense strategy. 2. Budget and investment implications. With a budget allocation of $6 billion, the AMCA program is a crucial investment in India's defense modernization efforts. This budget will cover research and development, procurement of materials, and production costs. Reports indicate that the total expenditure may exceed this initial estimate, driven by the complexity of integrating advanced technologies and systems. Impact on defense industry. The financial commitment will boost the domestic defense industry, creating jobs and fostering innovation in related sectors. Long-term sustainability. The emphasis on indigenous capabilities aligns with India's broader defense policy, reducing reliance on foreign imports and enhancing self-sufficiency. 3. Advanced AI integration. A defining feature of the AMCA program is its planned integration of advanced artificial intelligence systems. This will enhance the aircraft's capabilities in several key areas. Autonomous operations. AI will enable the AMCA to perform autonomous missions, improving operational efficiency and reducing the risk to human pilots in high-threat environments. Advanced targeting systems. AI-driven algorithms will enhance targeting accuracy, allowing for better decision-making in real-time combat scenarios. Data analysis and predictive maintenance. AI will streamline data processing, enabling predictive maintenance and reducing downtime, thereby extending the aircraft's operational lifespan. The successful integration of AI will position the AMCA as a competitive platform in modern warfare, aligning with global trends in military aviation. 4. Strategic implications for India's defense landscape. The successful development and deployment of the AMCA will have profound implications for India's strategic posture. Enhanced deterrence. A modern fighter aircraft will significantly enhance India's deterrence capabilities, particularly in the context of regional security challenges. Strengthening alliances. The AMCA could serve as a platform for collaboration with other nations, fostering defense partnerships and technology transfer agreements. Influence in regional politics. A strengthened air force with indigenous capabilities may alter the balance of power in South Asia, allowing India to assert its influence in regional politics more effectively. Conclusion. The AMCA program is set to redefine India's military aviation landscape by 2036. With a phased development strategy, substantial budget allocation, and advanced AI integration, the program reflects a comprehensive approach to enhancing the country's defense capabilities. As the AMCA moves through its development phases, it will not only bolster India's indigenous defense industry but also position the country as a formidable player in the global defense arena. The successful execution of this ambitious program will be crucial in shaping India's future defense capabilities and geopolitical standing.